And welcome back, students, as we get into our next topic, which is that of patterns in sorting. So today we're going to start off by discussing that of divide and conquer algorithms. So getting started, a pattern or patterns are, in our aspect for this lesson, design outlines that can apply across a variety of software applications, whether you're looking at making a video game or you're looking at something such as a air traffic control system. There's going to be patterns involved. Now, in order for us to use patterns, typically they have to be useful. All right, so they have to be able to apply across a variety of situations. Think about the video game example. When we start looking at patterns, maybe we're looking at, combat. Let's say you're going to fight an enemy. That's a pattern that could occur. So what would be a useful thing? Well, how do you handle that combat? Are you using something like a turn-based system, using real-time action? Is it an FPS? So obviously, it's a pattern that we can use because it's appropriate to multiple types of situations. It needs to be substantive, so the pattern has to be able to make some assumptions about the domain of applications to which it applies. So in other words, if we use our video game example, we have to be able to say, hey, we're going to assume certain things that are going to be necessary in order for this application to be developed. So we're going to look at one of the more well-known patterns, which is that of the container iterator pattern. Well, a container is a class or another construct whose objects will typically hold multiple pieces of data. A great example of a container is that of an array. Because remember, an array is just a collection of objects or a collection of characters or a collection of strings or a collection of ints. It's a collection. So some other examples, which we're going to discuss later on in Programming 3, are things such as vectors and also linked lists. So if we talk about this container iterator, any class or other construct designed to hold multiple values can be viewed as a container. Because think about it, classes can have multiple data types. You can have multiple ints, you have multiple chars, multiple strings, etc. So for example, string value, the way we define strings in Java, can be viewed as a container that holds the characters in the string. If you look at other languages like C#, for example, there's a string with an uppercase s and a string with lowercase s. Java doesn't really have that because Java string is just a class. We don't have to worry about a primitive string type. Now, any construct that allows you to cycle through all the items in the container would be that of an iterator. So, for example, an array index is an iterator from array because when we look to count through the array, we want to say what's in array 0, array 1, array 2, etc. We look at the array index. Index by default starts at 0. So an array iterator, for this case, can cycle through as follows. For int I is less than 8 length, I++, do something with a of I, whether it's count it, add it up, etc. Now, obviously, the index variable in this case is I, and that's our iterator. The container iterator pattern also describes how an iterator is used on a container. All right, and that leads us to this next thing, which is known as an adapter. An adapter, or adapter pattern, depending how you want to spell it, there's just a flavor text here, to transform one class into a different class without changing the underlying class, but merely just pretty much adds like a new interface. So the new interface then replaces the old interface of the underlying class. So let's take an example of this, which is the stack data structure, which is used, among other things, to keep track of recursion. We haven't been talking about that last couple lessons, have we? So one way to create a stack data structure is start with an array, and then add the stack interface. The adapter pattern says start with a container, such as an array, and then add an interface, such as a stack. All right, so all this is going to lead to our model view controller, all right, which is kind of what I have here in our diagram. The model view controller is a way of separating the input-output tasks of an application from the rest, because obviously input-output is very important to the user because they're going to be entering, data and commands in, and they're going to be expecting a result out. But obviously there's other stuff that's going to be going on behind the scenes. Now, if we look at this, there's three parts. So obviously you have the model, you have the view, and the controller. The model part of the pattern performs the heart of the application. So this is where the bulk of your computations and stuff like that are going to go on. The view part is the output part. It displays a picture of the model state. All right. This is what when we run our application, what the end user is seeing. The controller is the input part. it relays commands from the user to the model. So this is what the user is typing, it's what the user is clicking, etc. This is the part that is getting input. Now, normally each of these three interacting parts is realized as an object with responsibilities for its own task. So, for example, if I use the example of video games we talked about earlier, the controller might be a keyboard class that just gets input from the user. Then the model would be the actual algorithm that computes what the keyboard is generating, and then the view would be the code to render it. So it might be like a scene generator. Now, the model view controller pattern is an example of what's known as the divide and conquer strategy. So pretty much what that means is you take one big task and divide it up into three smaller tasks with well-defined responsibilities. If we looked at the example we gave, we said that there's an input side, an output side, and then there's the model side, the heart of it, the algorithm part where it does the big meat of the operations. So as a very simple example, the model might be a container class, such as an array. The view might display an element of that array. So it's like, hey, I want to see what's in an array of 2. Okay, so view is going to display, like there's console or GUI element, what's in 2. The controller is going to give the commands to display the element at specified index. So, it might be a method call, for example. The model or the array then notifies the view to display a new element whenever the array contents change or a different index location is given. Now, any application can be made to fit the model view controller pattern, but it's particularly well suited more towards GUI elements or design project, graphical user interface, where the view can be a visualization of the state of the model. Command line sides, which is what we've been doing, not quite as good. So, but the GUI, of course, is a simple interface for windowing of the form we find most modern software applications, as opposed to the simple text I/O that we've been doing. Most of what we're doing, hey, it's a program, it runs, but everything we're looking at is technically through the command line rather than through the GUI interface. Now, if we look at this, no matter what, the model might be an object to represent, let's say, your list of computer desktop object names. So what's on your desktop? Well, the view could then be a GUI object that produces a screen display of your desktop icons. The controller relays commands to the model, which of course is the desktop object, to add or delete names. The model object then notifies the view object when the screen needs to be updated. So that means, for example, let's say you have a file on your desktop, and you say, you know what, I want to rename this. So you choose, like, let's say, right-click, rename. Well, when you right-click, rename, that would be the controller relaying commands. Hey, the user's renaming this file, and then pass that to the model, and then the view says, oh, you renamed it from file 1 to file 2. I need to change it so that way the user sees that reflection. All right, now we're also going to look at this with another example here, all right, because it's pretty easy to understand the I/O side of things, but the model side might be sometimes a little bit more hard to kind of wrap our mind around of how you could use that in an application besides I/O. And the application we're going to use is that of a sorting pattern. Now, the most efficient sorting algorithms that are out there all typically follow a pretty similar pattern. Expressed recursively, what they tend to do is divide the list of elements to be sorted into 2 smaller lists, recursively sort the 2 smaller lists, and then recombine the 2 sorted lists to obtain the final sorted list. So obviously there's recursion going on. This pattern is expressed as pseudocode, in fact, almost completely correct Java code that we're going to look at, for a method to sort an array in increasing order using the lesson operator on the following slide. So here we have precondition, the interval a begin through a end of a have elements, post condition. The values in the interval have been arranged so that a begin is less than or equal to a of begin plus 1 all the way up to a of n. So here we have public static void sort type array a int begin int end. If end minus begin is greater than 1, int split point is equal to split a comma begin comma end. Sort a comma begin comma split point. Sort a comma split point plus 1 end. Join a comma begin comma split point comma end. So let's actually break this pseudocode down. Our sorting pattern is using a divide and conquer strategy. All right, divide and conquer, of course, we're not talking about the military application here. We're talking about the software application. Is dividing that entire collection of elements to be sorted into two smaller collections, which in turn sorts the smaller collection by recursive calls, and then combines the two sorted collections in order to obtain the final sorted array. Now, although the pattern does impose some minimum requirement on the method split and join, it does not say exactly how the methods split and join are defined. Different definitions of split and join will yield different sorting algorithms. So the method split rearranges the elements in the interval a begin through a of n and divides the rearranged interval at a split point with a split point. The two smaller intervals a of begin through a of split point and split point plus 1 through a of n are then sorted by a recursive call to the method sort. You'll note that the split method both rearranges the elements in the array interval a begin through a of n and returns the index split point that divides the interval. After the two small intervals are sorted, the method join then combines the two sorted intervals to obtain the final sorted version of the entire larger interval. Now, you'll note that the pattern says nothing about how the method split rearranges and divides the interval a begin through a of n. In a simple case, split might simply choose a value split point between begin and end and divide the interval into points before split point and the points after split point with no rearranging. So we're going to examine a sorting pattern by defining split this way in the following lesson. On the other hand, the method split could do something more elaborate, such as move all the small elements to the front of the array and all the large elements towards the end of the array. This would also, in this case, be a step towards fully sorting the values. Now, we're also going to look at in our next lesson another sorting pattern that utilizes the second approach. So we're actually going to look at two new sorting algorithms when we get into the next lesson. Right? And of course, on the topic of sorting algorithms, if you remember, up to this point, we have discussed the bubble sort, which is a super easy sorting algorithm, but it's considered to be highly inefficient in terms of runtime. And we've also discussed selection sort, which is like a slightly improved version of the bubble sort. So it still has pretty terrible runtime. Better than I have a bubble sort, but not quite as bad. All right. But that being said, we're going to stop right here today, folks, and I will see you next time.